Dear students, in this video we are going to see modular exponentiation and encryption. Before that, here first we will see how to convert decimal into the binary. Now you see this example, 156 is a decimal number. We have to convert this decimal number into the binary. Okay. Now see, write 156. You divide this 156 by 2. So that quotient is 78. What is the remainder? That is 0. Next, you divide 78 by 2. The quotient is 39. The remainder is 0. Similarly, you do that. Okay. Now you see here, I am getting 2. So you divide by 2. So 1 multiply 2. The quotient is 1. 1 multiply 2 is 2. So the remainder is 0. Okay. Finally, you see here, 1 is there. So we have to divide by 2. So 2 multiply 0 is 0. The remainder is 1. Okay. So now you list all the remainders from bottom to top. That is here. From bottom to top. So 1 0 0 1 1 1 0. This is a binary of this decimal number. We will see modular exponentiation. Okay. B to the power n modulo m. How to calculate this? We can apply the modular exponentiation algorithm. Okay. What is the procedure for that? You see here, this b is an integer. Okay. And n comma m are positive integers. Okay. Now first we have to convert this number, this n, into the binary. Then you have to write n is equal to in binary form. After that, to start this algorithm, we have to assume that x is equal to 1. Okay, when we start this algorithm, we have to assume that x is equal to 1. And we have to write power. What is power? Power is equal to b modulo m. Now, what is given b in the expression that you write, then write modulo m. That is called power. Okay, these two values we have to assume before starting this. Okay. Now for I is equal to 0 to k minus 1, if ai is equal to 1, then x is equal to x multiply power modulo m. Power is equal to power multiply power, which means power squared modulo m. We have to do this loop until we complete all these values of a0, a1, a2, etc. a minus 1. Okay. Finally, you get some value x. That x is nothing but equal to our required b to the power n modulo m. Okay. When we see an example for this algorithm, we can understand better. Now we will see this question. Find 3 to the power 644 modulo 645. Okay. What is given? Use modular exponentiation algorithm to calculate this. Okay. Now, what we have to do first? You see here, what is given in the form? That is b to the power n modulo m. So, I write here, the given question is on the form b to the power n modulo m. Okay. So, that we can write, what is b? b is equal to 3. Yes. Now, what is n? n is equal to 644. Okay. What is m? That is 645. Okay. Now, to apply the modular exponentiation algorithm, we have to write a binary form of this n. Okay. That is here, the first step. Now, so that what I do here, see here, what is the value of n? n is equal to 644. Okay. Now I write the binary form of 644. Okay. Now you have to follow this method to write the binary form of 644. Okay. So what is that? 1 0 1 4 times 0 and then 1 0 0. This is the binary form of the decimal 644. Okay. Now, what is this? See here, I am writing the general form. A0, sorry, A9, A8, A7, A6, A5, A4, A3, A2, A1, A0. Okay. So now you see here, this is A0, this is A1, this is A2, A3, A4, A5, A6, A7, A8, A9. Okay. Now we are ready to apply the algorithm. But when we enter into the algorithm, before that we have to assume what is the value of x. So value of x is 1. Okay. Then how to calculate power? Okay. So that here I assume that value of x is equal to 1. Okay. And how to calculate power? Power is equal to, what is the rule is given here? B modulo m. So now here B modulo m is nothing but, see, B is 3. B is 3. Okay. Modulo m is equal to 645. So now you see this is small number. Our modulo m is 645 is bigger than this 3. So the remainder is 3. So that I can write power is equal to 3. So before apply the algorithm, we have to find the binary form of the given decimal number 644, and then we have to assume that what is x. X is 1 always, and then we have to find the power. What is power? That is 3. Okay. So now we can start the algorithm. We can start that loop, for loop. What algorithm says? We have to start from this value a0. What is a0? A0 is equal to 0. You see here. First we will start this loop from I is equal to 0 to k minus 1. So what does here I is equal to 0 means a0. What is a0? See, a0 is 1, then you have to calculate x, new x. If a0 is equal to 0, then you have to take the assumed value of x. Okay, that's what here. You see here, we start from a0 to do this, to apply this for loop. So a0 is equal to what? A0 is equal to 0. So first, for I is equal to 0, what is a0? A0 is equal to 0, first value. See, a0 is nothing but first value. Here, from right to left, I am checking. So now 0. So a0 is equal to 0. If 0, what you have to do? Already what you assumed for x, you have to take that one. Okay? Yes. So now x is equal to 1. Okay. In this loop, each time you have to calculate power. Okay. What is power? Power is nothing but, you see the rule. Power is nothing but power multiplied power, which is power squared modulo m. Okay. To calculate the new power, you have to multiply the previous powers, then apply the modulo m. So now what I am doing here, see, already what I found for the power, that is 3. Okay. So now what is the new power? That is 3 squared, because the rule is power multiply power. So 3 squared. Okay. So that 9 I am getting. So 9 modulo 645. See here 645 is bigger number. So the remainder is 9. So that is 9. Okay. Now what is the second one? A1 is equal to 0. See now how? Because this value is a1, second value. What is here? A1 representing 0. So now a1 is equal to 0. You see here, again I am telling, if this value is 0, you have to take this previous x value. See here, x is equal to 1. So I am taking the same. Okay, x is equal to 1. But the power you have to calculate. Okay, every time. So now power is equal to, what is the previous one? Previous power is 9. So take this 9, put here 9 into 9, that is 9 squared, 81. Again 81 is a small number, but here modulo is 645. So that the remainder is 81. Okay. So when you apply 81, when you do 81 modulo 645, the value is 81. Okay. This you already studied in week 1 itself. Okay. Now what is this? Next, A2. Okay. A2 is equal to, now come to the loop, come to the algorithm. A2 is equal to 1. See here, your value is 1. If your value is 1, then what you have to do? You find the x value again. You have to find the new x value. Understand? Now you see here, this value is 0. So I take the assumed value of x. Here also this value is 0. So I take the previous value which I have, that is x is equal to 1. Now but here a2 is equal to 1. You see here a2 is equal to 1. So now what I have to do by algorithm, I have to find the new x. Okay, what is the rule for new x? X is equal to x multiply power, then apply modulo m. Okay, so now you see here I have to calculate the new x, that is equal to, what is the old x? That x1 multiply this power. What is the power? This one, last value, that is last power, that is x1, sorry 81. So 81, so 1 multiply 81, that is 81. Okay, this value is x, understand, x. Now we have to calculate the power. Okay, because each time you have to find power. Okay, power, what is power now, is equal to the previous power square. So 81 multiply 81. Okay, that for that value is this one. Okay, now apply the modulo 645. See here 81 modulo 645, this is small number than the modulo value, so that I write that 81. Okay, but here this is a big one, so what you have to do, you write 6561 is equal to 645 multiply some value plus you will get some remainder, that remainder is called 111. Understand? See here 6561, see 6561 modulo 645 I have to calculate, that is 6561 is equal to, can be written as 645 multiply 10 plus 111. Now the remainder is here, your answer. Okay, this is the way how to calculate this 6561 modulo 645. Okay, now next, see until a2 we have calculated. Now what is a3? See a3 is nothing but this 0. Okay, you see here a3 is 0. When you get this value 0, don't calculate new x. Okay, that is important. So now what is the previous x? That is 81. So that you take that 81. Understand what I'm telling? See, whenever you have here 0, okay, then use the previous x. Okay, now but you have to calculate power every time. So now power is equal to, as usual, you multiply power into power, means power square. Okay, previous value, so previous power is 111. Okay, so now here 111 square modulo 645. So now you have to calculate this value, this is 12321, apply the modulo like this, then you will get the remainder 66. Okay, I hope you understand the loop, means for loop. Okay, now we have started this a0, then a2, then a0, a1, next a2, next a3. So we have to do a4, a5, a6, a7, a8, a9. Now you see the last one, a9, the last one, a9 is equal to 1. Okay, so now a9 is equal to 1. So what we have to do, we have to find the value of x. Okay, this is the last in our loop, in our process, this is the last value. So now a9 is equal to 1, so we have to find x. So what is x? The previous x and multiply the power, then apply the modulo. Okay, so now that is previous x, that is 471, then previous power is 111, you multiply both, then apply the modulo, you will get the remainder 36. Okay, then you can stop the process. You see here, you see the algorithm. Now you see, finally you have to calculate the x, that x equals your b to the power n modulo m. Now you see here, this is the x, see final x is this, x is this 36. So now what is your question? 3 to the power 644 modulo 645. So what you are getting, this x value when you stop the loop, when you stop the algorithm, that is called your final answer of the given modulo, that is 3 to the power 644 modulo 645 is equal to nothing but this value, that is 36. That's it. Thank you.